Okay. So again, we only have really two shortcuts that we can use in order to take the derivative. I guess we have some other things like properties and stuff like that too, but really two main shortcuts, right? The derivative of a constant, and the derivative of a constant we know is 0. We also have the power rule. So if we take the derivative of like x to the n, we know the derivative of x to the n, where n is an integer or n is a rational number, is n x to the n minus 1. And then of course if we have like a sum or a difference of those things, we can take their individual derivatives. And we can also, if we have like 2x squared, right, its derivative is just going to be 4x. So we've had like a constant in front or a coefficient. Then you just like multiply, with the coefficient in front, stuff like that. All right. But for the warm up, right, and for also some of the homework and stuff like that too, sometimes you run into, some things that we want to rewrite, okay, before we maybe take the derivative. So for example, let's consider, and I'll do an easier one than the warm-up was. Let's consider f of x equal to the quantity x squared times x to the fourth. And I'm off the screen. There we go. Okay. Consider the function f of x, which is equal to x squared times x to the fourth. Okay. What I'm going to do first here is try taking the derivative of f by taking the derivative of x squared and x to the fourth and multiplying together. Okay. So what I'm trying to say here is we learned yesterday, right, if we have two things being added together, and I want to take the derivative of that function, right, if I have like x plus 1, if I want to take the derivative of that function, I can take the derivative of the individual parts and then just add them back together. Can I maybe do that for multiplication? So in other words, here with x squared and x to the fourth, can I take x squared and just take its derivative and then take the derivative of x to the fourth and then just multiply them back together? Can I do that? Well, let's see here. What is the derivative of x squared here? So, right, x squared, derivative of x squared is going to be 2x. What's the derivative of x to the fourth? 4x cubed, or 4x to the third. Okay. Which then, if we multiply that out, what does that simplify to be? 8x to the fourth, right? So now, simplify f of x, then find f prime of x. Okay? Simplify f of x, then find f prime of x. So in other words here, f of x, which we have defined as x squared times x to the fourth, okay, what is x squared times x to the fourth? X to the sixth, right? You add exponents when you multiply. Okay. And now we'll find the derivative of x to the sixth. What is the derivative of x to the sixth? 6x to the fifth, right? Okay. What do these results show us here? Yeah, it doesn't work, right? Which one's right? First one or the second one? Second one, right? Because in the second one, we did stuff we know we can do, right? We know we can multiply x squared times x to the fourth and get x to the sixth. And then we can take the derivative of x to the sixth, no problem, get 6x to the fifth, right? So the fact that this is equal to this, and then to take the derivative and get that, this should be right, right? It's this one where we were like not so certain about, taking the individual derivatives, okay, and then, excuse me, and then, multiplying the derivatives, the individual derivatives back together to get the final derivative. So clearly these things are not equal, and so this is not how you do it. Okay? So in other words, dx, the derivative with respect to x, of f of x times g of x does not equal, so equal sign with a slash through, I'm going to actually spend the time and write it out here, does not equal, in general, f of prime of x times g prime of x. So please do not do that. Okay? We just showed you a counterexample here of this, it doesn't work, right? So that's why we know it's not in general. In general, it's not true. Okay. Okay. So then, is that it then? Every time we have a product, do we have to actually like multiply it out and then take the derivative? Or is there a way we can take the derivative of a product? Well, the answer is we can. We can take the derivative of a product. Now, what I'm going to write next, you're welcome to follow along and write it down if you want to on your own piece of paper. It's a lot. I'm going to just say that right now. So if you would prefer just to like follow along with me as I'm writing stuff down and talking here, that might be a better use of your time just because it's a lot to write out and I don't know how important it is. But, and again, some of you may get lost, and that's okay too, because I'm going to get to the summary at the end here. But I'm going to show you actually like how we can figure out what the kind of like rule is for finding the derivative of a product of something. Okay, so bear with me here. Just follow along. You really don't need to write this down. So here's the product rule. I'm going to show it to you using what we already know. Okay, but it does get a little messy. Okay, so in other words, let's say we got a function h of x, and it's equal to f of x times g of x. Okay? And I want to find the derivative of this thing. Well, what did we originally use to find the derivative of something? Limit, as h approaches 0, of, and my function here is f of x times g of x. So I'm going to do f of x plus h times g of x plus h minus f of x, g of x, all over h. Okay? So now, there's our derivative, but it's like, how the heck are we going to simplify this into any sort of like recognizable form? Well, I'm going to do something that's a little sneaky or tricky here that is helpful to our ultimate goal. So I'm going to introduce, well, so I'll keep the oh, now hang on a second here. I want to make sure I do this right. Okay, sorry, I made a mistake. This should be g of x plus h, yes. Okay, so f of x plus h times g of x plus h. I'm going to leave that part right there. I'm going to introduce in here some terms. I'm going to introduce a g of x times f of x plus h. I'm going to introduce, so a negative one of those, and I'll introduce a positive one of those as well, so that they really just cancel it out, right? So I'm really just adding in 0 here. But you'll see why I'm doing this in just a second. Okay, so all I did from step 1 to step 2, kept the f of x plus h and g of x plus h, kept the minus f of x, g of x, and I subtracted the g of x, f of x plus h, and I added the g of x, f of x plus h. And you'll see why in just a second. Okay. All right. I'm now going to take this down to here. I'm going to break up this limit. Okay? I'm going to group together this piece of the limit, and then I'm going to group together this piece of the limit too. Okay? So I'm going to break this limit up into two pieces. I'm going to have the limit as h approaches 0 of f of x plus h, g of x plus h, minus g of x times f of x plus h, right? So I just took this piece right here, and it's going to go all over h, plus, and then the limit as h approaches 0, and I'll take this piece now. So g of x times f of x plus h minus f of x g of x all over h, like that. So I broke up the fraction, right? There's that sum that we have right there. So it's this over h plus this over h, right? So I'm just breaking up the fraction. Now, in the numerator here, we have a GCF. What's the GCF in the numerator over here? What can we factor out from both terms in the numerator? F of x plus h, right? So I'm going to do that. And what's left in the numerator, it'll be g of x plus h minus g of x all over h, right? Plus limit as h approaches 0. And what GCF can I factor out from this one over here? G of x. Okay, which leaves behind then f of x plus h minus f of x all over h. Okay. Now, what's this going to be as h approaches 0? What does this just simplify to be? What's the limit of this as h approaches 0? What's it going to become? Just f of x, right? This is just f of x. So I get f of x. The limit as h approaches 0 of this, what is this? What is this?
0.
Not 0. The limit is h approaches 0. Sorry, I'm sorry, this h. What I mean is, sorry, the whole thing right here. The limit is h approaches 0 of this. What's another way we could talk about this? It's the derivative of what?
G.
Of just g. Yeah, it's g prime. So this becomes that. This becomes g prime. Right? F times g prime. Because again, we're taking the limit as h approaches 0 of that. Plus, okay, what's the limit as h approaches 0 of g of x? Bueller? G of x? Okay. What's the limit of this as h approaches 0? What is it? F prime. So this is h prime of x. Okay? So that is the product rule. That is the product rule. The derivative with respect to x of f of x times g of x equals f of x times g prime of x plus g of x times f prime of x. Okay? And different books flip it around in different ways and stuff like that, but either way, there's the rule. Okay? Do you need to know this? No. Do you need to be able to explain it? No. Not even for calculus. But you do need to know this. Okay? I showed this because I think you guys were capable of understanding it, okay, to one extent or another, so that's why I presented it to you. Okay? Not to torture you or to bore you, but really it's this is the craziest part right here. Putting in the minus g of x f of x plus h plus g of x f of x plus h, right? This is done by someone who is, maybe more creative or intuitive of a math person, than me, than I would be capable of, kind of thing. But when they did that, then the rest of the problem was pretty straightforward. So yes, Ramika. The product rule, yes. The proof of it, no. Yes, in calculus. So in calculus, yes, this is something you will have to have down. The first times the derivative of the second plus the second times the derivative of the first. Or, the second times the derivative of the first plus the first times the derivative of the second. However you want to remember it, you're going to need to remember it, though. Yep, absolutely. Okay. It will not be on a formula sheet given to you. But don't worry, Mike, when you go to calculus, if you go to calculus, you'll be practicing it so much, it'll be drilled into your head. Yeah. Maybe not at first, though. Maybe not at first. Okay, but anyway. All right, so let's try an actual problem using it. Alrighty? So let's say, for example, let's find h prime of x. Okay, we'll just do 1. h of x, maybe 2. h of x equals 3x minus 2x squared, and then times 5 plus 4x. Okay? Kind of want to keep this up here just so we can have the product rule handy here. Okay? So this thing, whose derivative we're trying to take, we want to try and break it up into 2 functions. So what might we want to designate as being like our f of x here? What do you say? Right? So h of x is a product of 2 things, right? It's a product of this times this. So we have f of x times g of x here. So maybe we could say that this 3x minus 2x squared, we'll call that like our f of x. Okay? And then that would leave the 5 plus 4x, the other part of the product. We'll call that like our g of x, right? So we know that h prime of x then is going to be, well, it'll be f times g prime plus g times f prime, right? So f means that we keep that piece the same, right? So it's going to be 3x minus 2x squared, right? There's the f piece, times g prime. What's g prime? Four, yeah, just 4. Plus, what's g? 5 plus 4x times f prime. What's the derivative of f? What's f prime? 3 minus 4x. There's h prime. That's it, right there. Okay, that's the derivative. Okay, there's f, there's g prime, there's g, there's f prime. Right there. Did we need to use the product rule here? Were we forced to use the product rule? And if not, what other option do we have here to take this derivative? So Parker, yeah?
Multiply it out.
Yeah. Yep. Boil it out and then take the derivative using our original method. Okay, so it's not necessary here. Okay? Not necessary. But we won't always be able to do that. For example, let's say that h of x is x squared times the sine of x. X squared times the sine of x. Okay. Can we multiply out x squared times sine x? Like we could here? Can we multiply that out? Can we simplify this anymore? Okay. So in order to take this derivative, we have to use the product rule, right? Have to. Now we're going to run into a problem, though. What's the problem we're going to run into when we go to take the derivative here? Yeah? Anyone? What's the problem we're going to run into? All right, I'll hold off. Okay, so let's break this up, right? We have 2 pieces. Again, let's call this x squared. We'll call that f of x. And we'll call sine of x g of x. Okay, so again, for h prime of x, we're looking for f times g prime plus g times f prime. Right, that's our formula again. So what's f? What is it? F is x squared, okay, times g prime. All right, what's the derivative of sine? Right, we don't know it yet, right? That's the problem. We don't know what the derivative of sine is, so I'm going to give that to you right here real quick. The derivative with respect to x of sine, okay, and there's a proof for this too. I'm not going to go through the proof with you. That's more than I want to worry about right now. And plus, I don't really remember it off the top of my head. The derivative of sine is, ready for this? Cosine. Crazy. Derivative of cosine? Close. Negative sine. And again, there's reasons for it. We don't have to worry about that right Okay, but just a little note right there. Derivative of sine is cosine, derivative of cosine is negative sine. So in other words, g prime then, if g is sine, g prime will be what? Cosine. Okay, g is sine of x times f prime, so that'll be times 2x there. Just like that. Okay, so there's our derivative. Right there. X squared cosine x plus sine x times 2x. Okay? Questions on any of that? Easy peasy. Ready for the next one? I'll take your silence as a yes. Okay. Let's do the same thing. Now consider f of x equal to x to the 6th over x squared. Okay, I'm going to go through this one a little bit quicker just because I don't want to, you get the idea here, right? So this is not a product, it's now a quotient. Right, we're dividing here. So let's try. Let's see here. Is f prime of x equal to 6x to the 5th over 2x? So in other words, if I take the derivative of just the top and divide it by the derivative of just the bottom, like this, right? So I took the derivative of x to the 6th and 6x, it becomes 6x to the 5th. If I took the derivative of x squared and make it 2x, is this f of x, f prime of x? Well, we can simplify this, right? What does this simplify to be? X to the 4th, and what's the derivative of x to the 4th? 4x to the 3rd. So can we take the derivative by just taking the derivative of the top and the bottom and then redividing them? No. Okay, that's what the derivative is. So there's a rule for quotients too. Okay, there's a rule for quotients too. I'm not going to go through the proof for this one because it's too much. Maybe some of you thought that the last proof was too much, but okay. If we want to take the derivative of a quotient of two functions, bless you, it's equal to g of x times f prime of x minus f of x times g prime of x. And you might be sitting there thinking, oh, that's kind of like the product rule, right? We have like one function times the other's derivative minus, because it's like division instead of addition, minus the first function times the derivative of the second kind of thing. All over the bottom squared. Okay, that's the quotient rule. That's the quotient rule. Okay, yes, Parker.
Is it just coincidence that the derivative of it and like the other thing, when you divide it out, it's 3x to the 4th, you swap the coefficient and the exponent, it's the same thing? I think in this case it is just like a coincidence, I think it is just coincidence. It just happens to be that. Yeah. But I'm glad that you're looking out for that kind of stuff too. Yeah. But I think it is just going to be a coincidence. Okay? This is a lot. And yes, like Ramika asked earlier, you'll have to have this memorized when you're in calculus. Okay? Either AV or ABC. Both of you guys will have to remember it. Okay? So there's like a little rhyme you can use to help you remember this. And if it's helpful, great. If not, well, you can just be entertained. Maybe. Okay? So if you think of g of x as like low, and I guess I should really spell that L-O-W, but I'm just going to use an L-O and the H-I for high. Okay? I'm just like abbreviating here. Let's just consider it that way. Okay? I know how to spell H-I-G-H and L-O-W, right? So low and high. Here's how you can remember it. Okay? Think of it as low times d high minus high d low over the square of what's below. So over the low square. Right? Low d high minus high d low over the square of what's below. It sounds like something like a leprechaun, let's say, or something like that. Calculus leprechaun. Okay?
What is it called?
So low d high minus high d low. And again, what does the d stand for? D stands for derivative, right? So it's low times the derivative of the top minus the top times the derivative of the bottom all over the bottom square. So low d high minus high d low over the square of what's below. I can tell you that I have calculus students that is how they memorized it. Okay, that's how they still remember it to this day. Okay, they remember it to like that. Okay, so we'll do one example with this, and then we'll have you guys try some. We'll have you guys get started on the assignment here. So we'll just do one. So let's just say find f prime of x. Okay, and we'll say f of x is equal to 5x minus 2 all over x squared plus 1. Okay. So here, with this problem, with this quotient, is it possible for us to avoid using the quotient rule here? Is it possible to avoid using the quotient rule? Like, can we simplify this? Not really. I mean, we can't really do long division here or anything like that. So we kind of we could break up the fraction, but I don't think that's going to be really helpful. So essentially here, we must use the quotient rule. Okay, so here's our high, here's our low, or f over the g there. So f prime of x will be low, x squared plus 1, times d high. What's the derivative of the top? 5. Minus high, the top, times d low. What's the derivative of the bottom? 2x. All over the bottom, the low, x squared plus 1 squared. Okay. I'm not going to have you worry about simplifying this right now. I just want to make sure you can take the derivative accurately. That's what I'm more worried about right now. Okay. Or, well, actually, we may need to simplify it for the homework. So I'm going to go ahead and simplify here. So we'll distribute the 5x squared plus 5 minus 10x squared. Oops, I should leave that in parentheses, minus 4x like that. I'm going to leave the x squared plus 1 unmultiplied out. Okay, so 5x squared minus a 10x squared gives me negative 5x squared, and then plus 4x, and then plus 5. Because again, it's minus a negative 4x, it becomes plus 4x. Say it like that. Okay, watch those subtractions, right? It's minus the quantity here. So when that 2x distributes, the minus sign will also distribute. So it becomes minus 10x squared, but minus a negative 4x, or plus positive 4x there. Okay, so there's our final answer. I don't know if that factors, but it won't cancel out with here anyway, so it doesn't really matter. So there's our final answer simplified. Okay, questions on any of that? Okay, you all look very eager to try some on your own. I know. You're holding our hand for too long, Mr. Widmeyer. We need to try it on our own. So I'm going to let you guys sink your teeth into this here. I'm going to say there are 8 on each side here. So there's some product rule stuff. There's some quotient rule stuff here. There's 8 on each side. I would ask that you do 3. Pick 3 from each side to do, okay, for your assignment. So pick 3, okay, on each side. So a total of 6. Yes. That's enough, please. You okay, Julia?
Are we going to finish that?
Nah, probably not. I just want to give you a taste of stuff. I'm not trying to drill and kill you. You know what I'm saying?
Alright.
If you feel like you need the extra practice, though, feel free to do some more. But I think you get the idea of what you want to talk about.
You're not my mom. Well, what did he say after that?
That's amazing. What will they think of next? Oh, my ice cream is now soup cream. Oh, I'm sorry, guys. Just one second. Yes, my freezer. I know. He's special, though. I'm not.
You're special.